Hello everyone and welcome to Geometry Lesson 4.3, Isosceles and Equilateral Triangles. Let's get started with isosceles triangles. Remember, isosceles triangles are triangles with two congruent sides, or two sides of the same length. We have some special terminology when we're working with isosceles triangles, and I want you to make sure that you're paying special attention to those terms because you're going to see them in the theorems that we'll talk about later in this lesson. So first, the two congruent sides of an isosceles triangle are called the legs. For this triangle, its legs would be segment AB and BC. The third side is called the base. In this case, that's segment AC. The angles on either end of the base that are made by the base and one of the legs are called the base angles. In this triangle, that would be angles A and C. So now that you know some of the basic terminology associated with isosceles triangles, we can talk about a couple of theorems. The first theorem is the base angles theorem. This theorem says that if two sides of a triangle are congruent, then the angles opposite them are congruent. So let's look at this one a little more closely. The hypothesis of the theorem says two sides of a triangle are congruent. So we're talking about isosceles triangles. The conclusion says that the angles opposite the congruent sides, which would be the legs, are congruent. So remember, an angle opens up to the side it's opposite of. So the angle opposite segment AB is angle C, and opposite BC is angle A. Remember any other terms for those angles? Those are the base angles. So this theorem could be shortened a bit to say, in an isosceles triangles, base angles are congruent. Let's look at another theorem. This is the converse of the base angles theorem. Hopefully you remember what converse means. If you do, you can probably guess what this theorem will say. Don't feel like guessing? Well, let's read it then. The converse of the base angles theorem states that if two angles of a triangle are congruent, then the sides opposite them are congruent. In this theorem, we're using the fact that two angles are congruent to prove that the triangle is isosceles. Make sure you remember that it's the sides opposite the angles, not just whichever two you feel like marking. Okay, that's enough isosceles stuff for one video. Let's move on to equilateral triangles. Remember, equilateral triangles have three congruent sides. That means they're kind of also super isosceles. We have two theorems about equilateral triangles, and I don't think you'll be surprised about either one of them. The first theorem says that every equilateral triangle is also an equiangular triangle. We can do a pretty quick proof of this one by using the base angles theorem that we just learned. So remember, the angles opposite any two congruent sides have to be congruent. So we can pick a pair of sides and mark their opposite angles congruent. Since this is an equilateral triangle, we can spin it and pick a different pair of sides and mark their opposite angles congruent. So you can see that all three of those angles have to be congruent since each pair of base angles has to be congruent. The second theorem is really just the converse of that one, saying that every equiangular triangle is also equilateral. That one can be proved in the same way that we proved the equilateral theorem, but with the base angles converse. So to sum up both of these theorems, any triangle that's equilateral must also be equiangular. They can't be one or the other, they always have to be both. So now that you've learned the theorems, let's try a couple of problems where you'll need to apply them. These first three problems will help us figure out what the base angles theorem and its converse actually mean. So in the first problem, it just says to complete the statement. It says if angle DBE is congruent to angle DEB, then which two segments have to be congruent? So let's mark on here which two angles those would be. And so if I look to the sides opposite them, the side opposite angle BED would be BD, and the side opposite angle EBD would be side DE. Because of the converse of the base angles theorem, I know that those opposite sides have to be congruent. So I can say that segment DE is congruent to segment BD. In the next example, I'm given two congruent sides, and I'm trying to figure out which two angles would have to be congruent. So it says segment AE is congruent to segment DE. So make sure you realize that this is part of this big triangle, triangle AED. And so the two base angles have to be a part of that triangle. So if I highlight that triangle, it might be a little bit easier to see that this theorem tells me that I'm talking about the opposite angles to those sides, angles A and D. Then in the last of these examples, we're told that segment HG is congruent to segment HK, and we're trying to figure out which two angles have to be congruent. So segment HG is here, and its opposite angle would be angle K. Segment HK is here, and its opposite angle would be angle G. So we're talking about this smaller triangle, triangle HGK. So if those two sides are congruent, then the base angles theorem tells me that angles G and K also have to be congruent. So the last set of problems for this video will help us to apply the base angles theorem and its converse and the equilateral and equiangular theorems to kind of solve some geometry problems. So in this first triangle, I'm given one angle. I know that it's an isosceles triangle, and I could ask you in a problem like this to find the measure of all the angles in the triangle. So the triangle sum theorem, we know that all three angles have to add up to 180 degrees, so we'll be using that. And we're also going to use the base angles theorem. So we have an isosceles triangle. Remember, that's what those two marks mean. And so let's start with the triangle sum theorem. I know that the measures of these three angles all have to add up to 180 degrees. So the measure of angle D plus the measure of angle E plus the measure of angle F all has to equal 180. And I also know from the base angles theorem that angles E and F, since they're opposite the two congruent sides, have to be congruent. So if angle E is 65, then angle F also has to be 65. So I can plug those into the equation that I wrote down below, and I'll have the measure of angle D plus 65 for angle E and 65 for angle F still has to equal 180. So a little bit of simplifying, and then I'll have the measure of angle D plus 130 degrees equals 180. Subtracting 130 from both sides will give me the measure of angle D, which is 50 degrees. In the next problem, I'm told that the two angles E and F are congruent, and I have expressions for each of the side lengths, and I need to figure out how to solve for x in this one. So the converse of the base angles theorem tells me that the sides opposite those angles have to be congruent, and congruent, remember, always means equal. So that means that 4x plus 4 has to be equal to 32. So subtracting 4 from both sides leaves me with 4x equals 28. Dividing by 4 on both sides gives me my answer, x equals 7. And you can always plug it back in and check. 4 times 7 is 28, plus 4 is 32. So I know that those two sides are congruent. In the next problem, I'm given an equilateral triangle, and I know that equilateral also means equiangular, so I can go ahead and mark that those three angles would have to be congruent. So algebraically, this looks a little bit confusing, but I want you to just remember that each of those three angles has to be the same size. So I could just assign a variable to them like x, but in this case I'm going to write it all out for you just so you can see the really concrete substitution method and all the different things that are happening here. So the triangle sum theorem tells me that the measure of angle A plus the measure of angle B plus the measure of angle C is all equal to 180 degrees. But since all three angles are the same size, they're all congruent, I can really just say that I basically have three angles that measure exactly the same as angle A. So I can put measure of angle A in for B and C. So then I'll have the measure of angle A plus the measure of angle A plus the measure of angle A, since they're all the same, has to equal 180. So 3 times the measure of angle A equals 180. And then if I divide both sides by 3, I'll find that that angle equals 60 degrees. So then all three angles have to be 60 degrees. And this is a problem that you'll probably never have to do again, because every equilateral triangle is equiangular, and any equiangular triangle, each of the angles measures 60 degrees. So if you can remember that, then you won't have to do this problem again. In our last problem, we're given an equiangular triangle. So first, remember that that means that it's also equilateral. So the two expressions that it gives me for the lengths of the sides have to be equal to each other, since those sides are congruent. So I can just set 6x plus 3 equal to 7x minus 1 and go through and solve the problem. So remember, first you want to subtract 6x from both sides to combine those like terms. Then we'll have 3 equals x minus 1. Adding 1 to both sides will give us our answer, 4 equals x. And this might be one of those problems where I'd ask you to tell me the length of each side. So you'd want to take the 4 that you found for x and plug it back in. And so I would find out that 6 times 4 is 24, add 3 to that, and it's 27. So the side lengths for each side of this triangle would be 27. That's all for this video. Remember, you can always go back and rewatch any parts of this video if there was something you didn't understand. Thanks for watching, and happy hypothesizing.